So hydrogen atom, we have to be in the last class. Most of you were absent that class. Okay. Anyway, so what was the idea is that you have the different types of motion and how we can treat them in quantum mechanics. How do we perform this quantum mechanical treatment for different types of motion? So now you understand, if you understand those things very well, then you will be able to analyze. Yeah. Uh, yes, that's okay. So we are going to apply those concepts that you learned last first semester and second semester about that was the vibration, translation motions, the 1D, 2D, and 3D, and then the harmonic oscillator, the vibrational motion, and then particle on a ring and particle on a sphere. So that learns all these things we are going to apply and understand. Simplest problem in real system, that is already done. This will have combination of all those things. Somehow, this is how to solve the hydrogen problem in quantum mechanics. That's what we are going to learn. And to give you an idea about this, so this was what I did in last class. I give you just an idea what how this all started. From where it all started? From learning about hydrogen atom, right? So the atom cannot be seen by naked eye. You can't see the electron. You can't see the atom. So the only way to know about their energy, their motion, is that through spectroscopy. So this was the first thing that first step in that direction. The discharge to the experiment performed discharge to this hydrogen gas in an electrical given an electrical discharge. The hydrogen gas is low pressure, and then you have create hydrogen atoms. Hydrogen atoms are some of them those exciting जो atom बनेंगे उसमें कुछ excited state में so some of those excited atoms that are created as a result of electric discharge they are in excited state and so there will be natural tendency for them to come back to the ground state and in the process there will be radiation and through that energy the energy loss will appear as a glow ठीक है यही तरह आगे आपको तो ये सारी चीजें मैंने क्लास में बताया मतलब बताया था if you understand what I did last class this one clear and so when you see a flow around the discharge you analyze that with the help of this something that this is the very fundamental of spectroscopy that you may say that you resolve you have a source of light. So this is the light that is coming from this discharge tube and it needs to be analyzed. So it passes in a slit and this mainly which resolves into the components. So the components so they appear at different positions on the as they appear as lines on the slit. That was the first idea, first hint that the energy of a hydrogen atom does not very continuous. Otherwise, we would have got sometimes lights here and sometimes here. No, these are like that. Anybody doing this experiment the same exactly the same function between these lines of these particular colors. So this was the first thing that was discovered by Bauer. So that's why we call it Bauer's rules. Right? Visible light है तो किसी और डिटेक्टर की जरूरत नहीं है, आपकी आंखें डिटेक्टर का काम करती है, ठीक है। तो सबसे पहले डिस्कवरी हुई वो शुरुआत बाउंड का। अब इसमें एक लाइन पे आप इंटेंसिटी बता सकते हैं, इंटेंसिटी को लैम्डा के बीच प्लॉट कर सकते हैं, दैट विल बी टॉलरेंस स्पेक्ट्रम, इंचेस स्पेक्ट्रम there. So I versus lambda that we can plot. So that is typical for an emission spectrum or this emission spectrum. So you have resolved into components. They are here at different positions. अगर इसकी जगह आपके पास वाइट लाइन का से बन है, पूरा एक कंटीन्यूअस कर देगा। एक वाइट लाइन का फोकस है, लाइट है या बल्ब है, तो आपके पास क्या होगा, उसी तरीके से पास करके एक कंटीन्यूअस स्प्रेडिंग ऑफ लाइट और वायलेट वीडियो है। बट यहाँ पे जो ग्रोथ है, जो मैग्नेट की डिजाइन पास करने से है, उसमें सिर्फ और सिर्फ ये 3-4 लाइन्स लगी है। That is giving you an idea that somehow the energies, so what is happening last time, बताया था कि हाइड्रोजन आयन से हाइड्रोजन से हाइड्रोजन एटम बन रहा है और some of these are excited state. तो excited state को हम स्टार से डिनोट करते हैं. This tends to come by coming back to ground state. This is ground state is coming back, and in the process it will release certain amount of energy that will be light. Yeah. So this is what happens. And this experiment that we are seeing is mixture of several wavelengths. तो sometimes mixed data जो ग्लो वहाँ पे दिखता है, ग्लो को हम एनालाइज करते हैं और इस डाटा एक्चुअली में वो जो ग्लो दिख रहा है, ग्लो जैसा वहाँ पे, that is a mixture of these lights, wavelengths of light, right? और जितनी बार इसको किया गया, वही पता हो सकता है। इसमें लाइट में बस इसे कॉम्पोनेंट So that is, you always get when you analyze this emission spectrum, you get this thing. So this was the emission spectrum. इसीलिए मैं एक काम करता हूँ, ये भी रखता हूँ. Yes. So it's better. So you always get this 656, 486, 434. सब exactly इसी पोजीशन पे हर बार जब भी आप ये एक्सपेरिमेंट करेंगे ऐसा ही होगा. Okay. So this gives you an idea. So this is what we call as gives you a hint that energy cannot vary continuously in the hydrogen atom. It has certain specific values and it can change in steps like that. So that was something that was कई बार गिरा. चलो कोई बात नहीं. पता नहीं मेरा कोई बात नहीं. सो ये है एक्चुअल हाइड्रोजन स्पेक्ट्रम, एमिशन स्पेक्ट्रम ऑफ हाइड्रोजन. सो दिस इज द फोटोग्राफिक प्लेट हैज अ डार्क बैकग्राउंड और इस पे जैसे ही एक एक कंपोनेंट ऑफ लाइट इट फॉल्स, यू सी अ ग्लो लाइक दिस. सो red line, blue line, purple like this that appears at different wavelengths. So this is something. So this is the quantization of energy. It reflects the quantization of energy in the hydrogen atom. So ये सब आपको बताया था कि you can have So similar thing you can think of in absorption spectrum, बस इसमें डार्क लाइन आएगी ब्राइट की जगह, ये भी डिटेल में लास्ट क्लास में बताया था. So we can move that. So initial जो एनालिसिस सारी हमारी हाइड्रोजन एटम को लेकर थी, सारी emission spectrum, emission of light emitted by the excited hydrogen atom. But the same thing can also be understood in the other way around. If you have hydrogen atoms in the ground state, hydrogen atom, not molecules, in the ground state, then you apply, give a continuous white light, continuous spectrum. So some of the portion at the same energy positions, there will be absorption and it will appear as dark lines. ठीक है? तो ये सारी सीरीज फिर एज द टेक्नोलॉजी हाइड्रोजन मॉलिक्यूल नेचर हाइड्रोजन एक्सिस्ट एज अ मॉलिक्यूल, राइट? आपको एटम समझना है तो एटम स्टेट में लाना होगा, so पढ़ेंगे ना वर्ड में. So that's why discharge rate में जो दिया इलेक्ट्रिक करंट पास हो गया, तो उस इलेक्ट्रिक जो एनर्जी आपने दिया the molecule gets individual atoms. और वो जो पहले हमने देखा कि वो एटम्स का है, सो वो ये जो पिक्चर था ना यहाँ पे, तो ये उसी चीज को दिखाने के लिए था कि आपने इस ट्यूब में क्या किया. हाइड्रोजन हाइड्रोजन बेसिकली एक्सिस्टेंस मॉलिक्यूल्स, मॉलिक्यूल्स को आप give electric discharge breaks into atoms, and then that atoms, some of them, either some of these atoms are excited states, different excited states. Okay. So they will gradually lose energy, come back to the ground state, and in the process, the energy will be lost in the surrounding as light, in form of light. Right? So that light, that emitted light, needs to be analyzed. That needs to be analyzed in detail. So first thing that we do, that it is a mixture of elements separate into components. Okay. So then you put a prism, you get different. So this is the simplest system of the hydrogen atom. एक एटम से पहले वन इलेक्ट्रॉन सिस्टम को पहले समझ लो, एक इलेक्ट्रॉन है. Then we go to the rest, multi electronic system that will be in the future. And after understanding that, we go to the molecule. Right. So so that's the thing. So emission spectroscopy was the first thing, atomic emission, that was gave you, that helped you in understanding the nature of hydrogen atom. ठीक है, एनर्जी आप कैलकुलेट करते हैं, तो एनर्जी से आपका मोमेंटम निकल जाता है, रेडियस निकल जाएगा, तो बहुत सारी आपकी चीजें आसान हो जाएंगी. So that's how it all started, and with that continuous spectrum, yeah. So then शुरू में से कॉमन इतना विजिबल लाइट है, दैट वाज only through naked light and those observations were made. Then later on, as technology improved, certain lines were found which were in the ultraviolet range. Certain lines were found which were near IR, infrared, near infrared. Right? So visible के से भी higher energy, ultraviolet, visible से कम energy वाला section, वो आपको नियर IR लाइट के फॉर्म में मिला. उसको डिटेक्ट करने के लिए आप टेक्नोलॉजी और करती है, समय के साथ जैसे as sophistication was achieved in instrumentation, we got this kind of things. And so power lines, in addition to power lines, other lines were also discovered. These were partial, backward, diamond. So you can see lambda, nanometer. So this is the power line which represents this visible range, visible vision. Okay. And beyond that, diamond, the ultraviolet, lambda का हो जाएगा 100 to 100 diamond. this side bracket question this was one near earlier. Other things. So this was the view, another view of the same thing. So this was explained by first explanation for this observation of spectroscopy was given by Bohr, Niels Bohr, and in that he imagined the electron to be moving in a circular path around the nucleus, that is one proton. Okay, so एक proton के around if the atom is moving in this path or this path, the energy will be different. And if it makes a transition, if it moves from this circular path to this path, accordingly the energy changes will appear. So here the energy changes because it is emission, so you can expect it to be coming from higher energy state, that is represented by the outer ones to the lower ones. So when we are talking about digital lines, that is the Balmer series, you can talk of it is coming to n is equal to 2. That is the second circle. The first circle is here, right? N is equal to 1. The second one is here, right? तो यहाँ पे कितनी दूर से आ रहा है n is equal to 6 से आ रहा है तो blue part of the spectrum and red one with the lowest energy, that is the next n is equal to 3. So this is the transition that happens. In the energy level diagram also it can be shown in the same way. So transition from higher values of n to the n is equal to 2, that gives you digital. So this was the okay, and then so ultraviolet light कब आएगी जब higher values of n and the electron is coming back to 1. So this is the highest energy transition, the set of highest energy transitions, and the energy is so high that it falls in ultraviolet region. And then infrared, visible color से कम. So n is equal to 3, you see the spacing is less. So this is the infrared lines that appear. So electronic models evolved over the time. This is the emission of energy that is represented. Then you have electron moving from outer circle, outer circular path to the inner circle, right? And there is energy emission. So there is a limitation of force, and it was not able to explain why, amongst other limitations जो बाकी सारी उसमें हैं, लेकिन सबसे बड़ा limitation यही था कि it was not able to explain why the energy is quantized. ये बाकी में आपको नहीं मिलेगा लिखा हुआ, लेकिन ये सबसे बड़ा drawback था. ठीक है, so why he only insisted that as long as stationary moving in a circle, the energy is constant. But why it is constant? So then you had D Broglie coming in, who evolved this equation that it gave the idea of wave particle duality and said everything, even the moving truck, moving vehicle, everything has certain wave-like character. So that is given by lambda h by a. Okay, so that was de Broglie's idea. So, but the same thing when you apply this, so this wave character is smaller for any macroscopic object, but such a particle as small as electron, the lambda is significant, the wave character is more dominant, right? So you have to take that into account when you are describing the energy motion of the electron around the nucleus. You must take into account. So that was not being done in case of Bose. Bose मॉडल का ये बहुत बड़ा फेलियर था. और ये मैंने फिर आपको बताया था कि हाइजेनबर्ग so has came up with the concept of uncertainty principle, and which we have already learned in quantum mechanics. So the position and momentum cannot be determined with precision simultaneously, and that uncertainty gave this idea that you cannot never talk about this circular path. Wire line path जो बना रहा था, वो कभी पॉसिबल ही नहीं. ठीक है, आप एनर्जी डिटरमिन करने की कोशिश करेंगे, और आज के कॉन्टेक्स्ट में हम जो जैसा मैंने कहा स्पेक्ट्रोस्कोपी हम यूज करते हैं Then spectroscopy focuses on determining the energies more precisely. So you are being more precise. So over the time, जैसा मैंने आपको कहा, over the period of time from the 19th century to till now, the technology has evolved and we have become more and more precise in determination of energy. जो energy आप determine करते हैं, wavelength determine करते हैं, वो ज़्यादा precise हो गया है। इसका मतलब आप position के बारे में तो और भी ज़्यादा imprecise हो गया है। You become less and less precise in the position of the electron, right? ऐसा सोच के देखो। हमारे पास पहले सिंगल बीम स्पेक्ट्रोफोटोमीटर होता था, डबल बीम स्पेक्ट्रोफोटोमीटर, समय के साथ जो इवॉल्व हुआ है उसमें सब में प्रिसीजन कहाँ बढ़ रही है? एनर्जी। एनर्जी का मतलब आप मोमेंटम, डायरेक्टली एनर्जी रिलेटेड ई स्क्वायर बाय 2 एनर्जी आप डायरेक्टली निकाल रहे हैं, मोमेंटम के साथ आप बहुत प्रिसाइज मोर एंड मोर प्रिसाइज विद द मोमेंटम। एंड इसको आप यहाँ पे अप्लाई करें, थोड़ा सोचें तो आपको खुद पता चलेगा इसके साथ। तो इसका मतलब ये नहीं हुआ कि हम पोजीशन के बारे में हमें और भी आइडिया कम मिले। ओके, so with that those thoughts in mind, it was better to, so the mistakes of Bose was clearly identified, and it was the wave nature was a more better way of explaining the electronic motion and its energies. So this task was done by Erwin Schrödinger, who combined these ideas of de Broglie and Heisenberg to evolve a new mechanics, quantum mechanics, wave mechanics, taking the wave nature of the electrons as the core, as the main theme. Okay, so the main thing is that was the that he assumed the electron to behave as standing wave. The electrons inside the atom then behave as standing wave, and standing wave, all standing waves, you will see a peculiar profile in all standing waves. Is that a standing wave, जैसा मैंने शुरू में भी कहा था, you have a pattern. If you see, you tie the string at two ends and plug the string. You plug in certain lowest possible energy, you will get one loop, then two loop, and three loops. So different. So if you try to calculate the wavelength, you will find that it is lambda. So the wave must have has to fit in the same length. So lambda L is equal to lambda by 2, L is equal to lambda, and the third one 3 lambda by 2. You can see three loops, each equal to lambda by 2. So the length of the thing is fixed, 3 lambda by 2. Or if you try to understand in terms of lambda, then you can, the first case and third case, you can see that lambda was equal to L by 1 in the first case. This second case, lambda was L by 2, and in third case, lambda is L by 2. So this present one, there is a pattern. You can see clearly see that जो भी standing wave बनेगा, उसमें lambda cannot have a guaranteed value. It can have only 2L by 1, 2L by 2, or 2L by 3. Nothing else. बीच का कोई value नहीं है. So this is the origin of quantization that I say. If you try to understand, you can also make a bold statement that all standing waves are quantized. So all the in daily life there is guitar, sitar, संतूर, हाँ, जो भी स्ट्रिंग वाले हैं, जितने भी ऐसे म्यूजिकल इंस्ट्रूमेंट्स हैं, सब में वो स्टैंडिंग वेव बनता है. Like the string, to get a sound. So all those are one of these waves. That is recently, ऐसा कुछ नहीं कि just wave quantum mechanics नहीं आप. So this kind of, so वो कहाँ से again boundary condition, यार standing wave जब भी होगा तो एंटी उसको जीरो है, एंटी को जीरो होना है. So this is a boundary condition. We always talk about the boundary conditions in quantum mechanics. जब भी equation होता है तो finite energy equation की वो किसी boundary condition apply करते हैं. So see, वो जो restriction उसकी वजह से So we see again emerging over here that the wavelength cannot have an arbitrary value, and it can have specific values as lambda is equal to 2 n by n, where n can be equal to 1 to 3 integer पर। ये जो n है इसी को तो क्वांटम नंबर कहा गया। ये जो नंबर एक ट्रेंड, एक जनरलाइजेशन ऑफ अ ट्रेंड, and then you see that it varies as a multiple of n, 2l by n. So n can be 1 to 3. So this is what is the origin of the quantization. This is the origin of quantization that we can talk about. So you should know the basic difference between traveling waves, standing waves, and all these things. Whenever you are talking about, we have been studying particle in a box model. वहाँ पे भी देखिए standing wave का equation करता है. It was all feature of standing wave that we have been seeing. Similarly, in any other things, particle on a ring, which is a standing wave. So all these things are. So here, what we are treating electron as a standing wave. कोई भी इलेक्ट्रॉन जो एक बाउंड न्यूक्लियस के चारों ओर घूम रहा है, दैट इज अ स्टैंडिंग वेव। अगर फ्री इलेक्ट्रॉन होगा तो वो ट्रैवलिंग वेव होगा, उसके लिए फिर एनर्जी का कोई भी रेस्ट्रिक्शन नहीं है, इट कैन हैव एनी वैल्यू ऑफ एनर्जी, एनी वैल्यू ऑफ लैम्डा। बट व्हेन the electron an electron is a part of an atom, then it behaves as a standing wave, and you can have only certain values of energy, certain value of lambda। ठीक है, तो यहीं से शुरुआत होती है और फिर हम आगे बढ़ते हैं। और श्रोडिंगर इक्वेशन ये सब आपने देखा है, समझा है, जनरल स्कीम ऑफ श्रोडिंगर इक्वेशन। नाउ वी कम टू दिस स्टेप बाय स्टेप एनालिसिस ऑफ हाइड्रोजन आटम। So treatment of so hydrogen atom consists of one electron, one proton. Okay, that is at the nucleus. So it is a typically two-body problem. Uh, yeah. So it is a two-body problem. One smaller mass, that is electron. The object with the smaller mass is electron, and the other one, this one, is your proton. So at location, if the coordinate system is running like this, so you have x, x1, x2, capital X, capital X2, and this is the center of mass. Center of mass, nucleus is heavy, so proton is heavier, so the center of mass will be shifted towards this side. So this is the one-dimensional system that we can think of. Uh, so total energy is sum of kinetic energy. So kinetic energy of particle m1, kinetic energy of particle m2, p1 square by 2m1, p1 p2 square by 2m2 plus the potential energy p. So इस तरह से then you can also write p1 as m1 dx. So velocity m into v, mass into velocity. So the coordinate x1 is changing with time. So dx1 by dt, p2 can be written as dx2 by dt. So the center of mass, location of center of mass, by this logic and applying the same rigid rotor के समय भी हमने मास को बैलेंस करके लिखा था, तो वो सब आप बैलेंस करके इक्वेशन लिखेंगे, you will get the position of center of mass in m1 by m, and so this is the total mass is m1 plus m2 given equal to m. So this x, this position can be defined as small x1, small x2 in terms of, so that is the individual. So separation of particles x2 minus x1, and so you can write. So the x1, the position of x1 can be written in terms of capital X, and you can substitute these values to get the individual values of x1 and x2. in this way. So m1 by m, here m2 by m times x, and then we have so we have so linear momentum of the particle express a rate of change of x and capital. So part T1 is so differential x1 by dt that can also be expressed by putting a dot. तो यहाँ पर हम लोग लिख रहे हैं x1 when we put a dot that is x1 by dx1 by dt, and similarly you can write x2. So इस तरह से हम इसको रिप्लेस करते हैं ये जो then you have this equation e1 m1 x1, and you can substitute this value of x1 here. Substitute this value, get it here, and you can write the equation for p1. You can write another equation for p2. So dx2 by dt m2 into x. So m2 to x minus. So coming from here, x2 has been substituted already. So dots represent the differentiation with respect to time. Dot means differentiation with respect to time. So, so this is this. So if you can so the two kinetic energy of the particles E1 square by 2m1, E2 square by 2m2 can now be written in form of half m1 plus m2. ठीक है? Total mass और दूसरा म्यू reduced mass. Total mass के terms में एक term and reduced mass. It is a sum of two kinetic energy sum such that एक total mass into one coordinate capital X वाला coordinate and small x वाला coordinate जो reduced mass के लिए यूज किया है उसके terms में हम इसको लिख सकते हैं small r. ठीक है? So mu is the reduced mass that you can write, and this one is the total mass. So reduced mass का मतलब क्या होगा यहाँ पे? प्रोटॉन है और इलेक्ट्रॉन. reduced mass क्या होगा? दोनों से कम होगा, मतलब इलेक्ट्रॉन से थोड़ा सा ऑलमोस्ट reduced mass will be almost equal to electrons. So sometimes for simplification we simply write mass of electron. reduced mass ना लिखते डायरेक्ट आप mass of electron भी लिख सकते हैं. So the same thing by writing p is equal to mx. So, another way to write the same thing, p square by 2m. So capital M, capital P is being used for the set total mass, and the small p being used for the this reduced mass. Reduced mass के लिए ये वाला term बस ये. So total energy you have to add the potential energy term here. So this was for only for kinetic energy. Kinetic energy for the whole mass as one unit, and the reduced mass, and then you add the potential energy term. You get this equation which can be generalized then. So if you get this equation, you can write the Hamiltonian. So center of the mass, you can write 1 x y z in three-dimensional coordinates, and for the reduced mass, again you can write uh, that expression for the energy operator. So that will cost. So this is the Hamiltonian. The total energy H. The Hamiltonian gives you total energy, kinetic plus potential. So, uh, so when the distinction is being made, uh, so there Are you following one thing? There are two coordinate system that we are using. कैपिटल एक्स जो है वो सेंटर ऑफ मास के लिए है और दूसरा जो स्मॉल एक्स दिख रहा है वो रिलेटिव कोऑर्डिनेट्स इन रिलेशन टू ईच अदर वो स्मॉल एक्स से हम डिनोट करेंगे. So the first term differentiates with respect to the center of mass coordinates, and the second term, which is here we are using the relative coordinates, that is being used. Center of mass और ये center of reduced mass. So मतलब total kinetic energy का दो part आ रहा है, एक total mass and variation of d capital X by dt. This is your velocity movement of the center of mass, and this is the mass taken together, and then you are taking as a taking the reduced mass, so mu, so sum of these two and its coordinate small x. इसका center of mass है. So overall function psi total can be written as, जैसा पहले भी हम दो किसी फंक्शन को करते थे, सम which is a combination of the two written in the multiplication forms for center psi for center of mass and psi wave function for the reduced mass. Second term that appears. Then once you write in this way, you will be able to write the total overall Schrodinger equation H psi total, which will be E total psi total, right? So the total energy then will be center of energy of the center of mass, energy of the that. So the separation and everything will work around the same thing that we did for particle on a ring and particle on a sphere when we separated them. And there is additional term, potential energy term. Potential energy term will be given by this V is better. Just you put the electrostatic uh, interaction. So it is the electrostatic interaction Z E square by 4 by epsilon R. So it's a negative sign and epsilon not is permittivity. So now, in, if we write the whole thing, so therefore the system can be written electron, the nucleus, kinetic energy of the electron plus kinetic energy of nucleus, and then potential energy of the system, nucleus plus electron. इलेक्ट्रॉन और न्यूक्लियस का उसको आप निकालेंगे. So subscript n, subscript e. So that is coordinates that you define for each. न्यूक्लियस के लिए अगर coordinate x y z define करते हैं, इलेक्ट्रॉन्स के point of view से जो coordinate define करेंगे, so that means x y z coordinates are differently defined, which gives you this two terms. So the generalized Hamiltonian operator that we have been writing in previous, so this becomes center of mass and then center of this nucleus that we are talking about. So, so the full Schrodinger equation will separate into two equations, one for the motion of atom as a whole through the space, and the other motion of electron relative to the nucleus. Motion of electron relative to the nucleus, ये reduced mass वाला है. This one it belongs to the reduced mass, and through motion through space as a whole, that motion is the one that we are talking about with the total mass. m1 plus m2 जो लेके चल रहे थे, वो ये वाला था. And this is the other one, yes, reduced mass. So two type of motion, one for the whole atom, one for the electron in relation to the nucleus. So मतलब आप ऐसे सोचिए न्यूक्लियस के अराउंड इलेक्ट्रॉन मूव कर रहा है सर्कुलर पाथ में, और पूरा का पूरा वो जो घूमता हुआ सिस्टम इलेक्ट्रॉन अराउंड न्यूक्लियस, वो फिर अपना इधर उधर रैंडमली मूव कर रहा है, ठीक है ना। जैसे ट्रांसलेशन ट्रांसलेशन हाँ, एक है इलेक्ट्रॉन का मोशन अराउंड रिलेटेड and the nucleus मतलब पूरा पूरा एटम का ट्रांसलेशन that is the transmission to that so total energy इस तरह से डिस्क्राइब की जाएगी और यहाँ पे आपका रिड्यूस मास आएगा, यहाँ पे टोटल मास आएगा इन दो सिस्टम में। ये चीज हम बार बार जो देख रहे हैं, so that is what is indicated over here. So internal motion of electron related to the nucleus will be psi epsilon r psi, where mu is the when we use look at here, यहाँ पे हम mu use कर रहे हैं, mu is the mass of electron, mass of neutron, me plus mn, and so when you are talking about reduced mass, mu is called the reduced mass. Reduced mass is so it will be similar to the mass of electron. जैसा हमने हर बार देखा है, आप कुछ न्यूमेरिकल सॉल्व करेंगे reduced mass का, you will realize that it is always smaller than, slightly less than the smallest particle that is being smallest mass that is being considered in the system. So here electron is the smaller mass, so it will be almost near about equal. Reduced mass will be closer to the electronic mass. So so now onwards we are replacing mu. let the equation जितना सिंपल दिख सकता है उतना हम कोशिश करेंगे. So now अब हम mu को हटा देंगे, mass of electron को ही यूज करेंगे for the internal motion of electron around the nucleus. That to describe that we will be using this mu will be replaced with me, mass of electron. So now तो अब तक हमने क्या किया था, particle on a ring, and then we extended it to like the particle will move from one ring to the other, and so that the movement of the surface. अब जो क्या होगा, ये जो इलेक्ट्रॉन्स का जो मोशन है इसमें एक और चीज हम ऐड कर दिया है. सो वो सरफेस पे मूव कर रहा था, अब इलेक्ट्रॉन एक सरफेस दूसरा सरफेस, मतलब एक छोटा बॉल उसके ऊपर एक कॉन्सेंट्रिक शेल्स, वी हैव सेवरल कॉन्सेंट्रिक जब सॉलिड स्फीयर बन जाए, वही ऑलवेज स्फेरिकल शेल था, सरफेस था जिसपे इलेक्ट्रॉन मूव कर रहा था. अब इसको हम एक्सटेंड कर रहे हैं, शेल विद इन द शेल, मतलब कई सारे शेल्स को मिला के, जैसे प्याज जस्ट लाइक अनियन वी हैव शेल्स विद इन द शेल्स, and that will give you a sphere, concentric surfaces, and allow the electron to move from one spherical surface to another spherical shell, one shell to the another. वो movement हम allow करेंगे, ये एक additional चीज यहाँ पर है, तब ये actual आपका इलेक्ट्रॉन का जो मोशन होगा वो डिस्क्राइब होगा. So we are allowing for in particle on a sphere we allowed electrons to move from one ring to the other. We visualize the sphere as a stack of rings. Stack of rings होगा, कभी भी solid sphere नहीं बनेगा, ठीक है ना, ये भी ध्यान रखने वाली बात है. अब हम solid sphere बनाने की कोशिश करते हैं, shell within the shell, उस तरह से उसको देखना होगा. So concentric surfaces, concentric spherical shells, one inside the other, and that extended in close. If you extend that vision, then you can see the sphere, solid sphere being generated. So, so, so we have the particle on a ring. We did that. R was defined as the distance from the axis, cylindrical axis, right? हमने हमेशा कहा आपको lines, cylindrical coordinates यूज किया. फिर हमने particle on a sphere. इसमें the R was defined from the center of the sphere to the any point on the surface. So R was fixed on the surface particle on a sphere. ये हमने visualize किया था, stack of rings. So R was kept constant and defined from the distance from the origin. Points to be noted. Defined as distance, R was defined as distance from the vertical line that axis of the cylinder, axis of the ring. Okay, here the r is defined, the radius r will be defined as distance from the origin, this central point, यहाँ से चारों तरफ, three dimensional space में, like this. So that was r. Now in third, so here we give the additional freedom for the particle to move from one ring to the other. Now what we are going to do, we are going to have one shell, another shell, like that. So ये spherical surface एक बना था जिस तरह से, अब इस surface को एक के अंदर एक ऐसा समा दिया. So R1, R2, so and then allow the particle to move from one sphere to another sphere, concentric spheres, right? So when you do this, so here we are viewing them as a stack of several concentric shells, concentric spherical shells. एक के ऊपर एक अंदर समाया हुआ. Okay. And give the freedom to, for the freedom, the particle is made free to move from one sphere to another sphere. So in this case r will be variable, it will not be constant. What? So yeah, r will not be. So three things, particle on a ring. So r theta phi ko raha, r is also a variable in this case. Particle on a ring, particle on a sphere, r was constant. There was a difference in how the r is being defined in case of ring and sphere. And now when we are going to this third, uh, the solid spherical view, the particle can move from one surface to the other surface. So we are visualizing here the sphere, solid sphere is visualized as a stack of several concentric shells. So then you know how we separate out this uh, in polar coordinates when we are changing the system from x, y, z to r theta phi. Psi will change from psi x, y, z, psi r theta phi. This is what we expect. And electron is here. Location of electron is here. This is the center, this is nucleus. And then you describe all the coordinates and the motion will be described in this. Therefore, we write r theta phi. So we again, as we did for particle on a sphere, we separated into two wave function which if multiplied, अगर हम इसको multiply करें तो original wave function generate होगा. Similarly, we are going to do few things here. So it can be separated. This equation separates into a function which varies only as r, another function y which shows variation in uh, amplitude with respect to angles. So एक angles पे depend करेगा, एक सिर्फ r पे depend करेगा, and this we denote as y. So we can substitute here. So we substitute the Laplacian in the three dimensions. X, y, z is replaced with r theta and phi, and we can write the radial part. Radial part is here. Variation of r, another dr del r square, and this one is the variation in angle, the Legendrian. So r, this r is here. Psi has been replaced with r, and y, r into y is the psi. Total psi is r multiplied with y. So in the same way, potential energy operator multiplied with the wave function. So r into y is our wave function here. Okay, and so energy into psi. Psi is r into y. So this is at the right hand side. So r depends on radius, y depends on angles, theta and phi, and the whole equation can be written in terms of in the same way. Uh, you can multiply these things, these terms. Then, when you are varying only r, y will be out of the differential, and when you have dr, so angles. So here r terms in last when you are multiplying with this one ry. So only angles will change. Angle is the variable r and r square. This will be constant. So that is the equation that you can get. So so we for separation of variables, we apply the same kind of arguments that we did for particle on a ring or particle on a sphere. That if you write it here, and right hand side is a constant. If sorry, if you write it here like so, if you vary only the angles, then this this term will be only the angular. This term will change. Okay, and so equation one. This one should be a constant depending on it depends on angle theta and phi. The other one which shows variation of r, that should also be minus जैसे minus ml square और plus ml square किया था हमने इसमें sphere वाले में separate किया था. In a similar way, we are assuming here that this should be equal to one constant and this part should be equal to another constant, because overall right hand side would become when you are putting it this way एक step missing है minus er square अगर यहाँ ले आए तो ये right hand side zero हो जाएगा. So constant and minus constant is coming from that side. So you take this er square term on this side. So right hand side will be equal to 0. So whole term that that is shows variation in r is put all together, and that should be equal to a constant. And if you take all those terms that appear that shows variation in the angles y, angular wave function, and angle legendary here and changing angle. So that will also be a constant but opposite sign. Okay, so constant and minus constant. So that is how we put it by the same set of arguments as we did in case of particle energy. So now we can write the constant that appears as h cross square L into m plus 1 by 2 mu mass. So p square by 2m, आप p square by 2m लिखते थे ना, और लीनियर मोमेंटम के लिए आपने L into m plus 1 इस क्रॉस लिखा था पहले. ये सब वहीं से आ रहा है. इसको अगर फॉलो करेंगे तो बहुत अब आप क्या मिस कर सकते हैं. जिस तरह की फिर आप दिक्कत कर सकते हैं. धीरे धीरे डेफिनेटली ये भी पूरा होता है. तो वहाँ पे क्या कर रहा है इस तरह और काइनेटिक एनर्जी इज दैट तो इस तरह को ये जो टर्म है ना, तो ये मास जो है मास ऑफ इलेक्ट्रॉन का यूनिट से मास ऑफ इलेक्ट्रॉन और ये पहले क्या आपको बताया इस तरह का नियम. तो वही यहाँ पे रिप्लेस किया होता है कांस्टेंट मास इक्वल एनर्जी के साथ. So putting it that way, we get so this particular term must be equal to h constant should be equal to ये जो constant है वहाँ पे जब हम particle और sphere था तब हम ml square के terms को रख रहे थे. यहाँ पे इस terms को हमें रखना होगा by 2m. So we immediately obtain an equation. So we substitute this value. If we substitute this value on this, in the previous one, we will get an equation that is del square sorry क्या है Legendrian. Legendrian का स्क्वायर जो Legendrian है. So we are substituting from here. This constant is being written as that L into L plus 1 h cross square by 2 mu, and so that constant term is written and you rearrange this equation. तो rearrange करेंगे del square और ये mu y सब इधर आएगा constant का value. So this is appear like this. uh, the equation is same, so rearranging the equation and writing the constant as this gives you minus L into L plus 1 y. So equation is same as the Schrodinger equation for particle on a sphere. Spherical harmonics will still be valid. तो इसीलिए वो समझना बहुत जरूरी था क्योंकि इलेक्ट्रॉन का सारा कुछ वहीं से समझ में आ जाएगा. तो L and ml quantum numbers will specify the momentum, angular momentum, and z component of the angular momentum. L, ml, angular momentum of particle. Okay, so that is the angular part is done. Appearance of the second separated equation. The second equation depending on r. So that was this simple d2r by dr square mu r dr by r. So this equation appears. So the radial distance. For the radial distance, sorry, r. And for this, we define another simple to simplify further. So capital R was the wave function that was written for. That shows the variation in the waveform amplitude with respect to r, small r, the radius. Now here we define further another function u, which is related with capital R with this. So small r multiplied with capital R equal to u, or you can write it in this way. That will further simplify your equation to this form. So if I substitute this value as u, this is not mu, mu is here. Difference है ये mu है ये u है. This is u, and u is equal to capital R into small r. So you can clearly see in the previous slide we had so wherever the term of capital R and small r was appearing uh, like this, there you will have, you can write u, and when you write in terms of u, this is the radial wave function. This equation will be called radial wave equation or radial wave function. uh, this is the radial wave equation, and solving this u is the radial part of the wave function, that radial wave function. Okay. So particle on a mass, a particle of the, this equation describes the a mass mu that moves in a linear way. So जो along the radial distance में जो movement होगा वो सारा इसके through describe होगा. That r can vary from 0 to infinity. So effective potential V effective is so potential energy क्या होगा electrostatic. यहाँ पे ध्यान दीजिए बहुत जगह ये चीजें नहीं लिखनी मिलेगी आपको. पोटेंशियल एनर्जी तो इजी है, इलेक्ट्रॉन है प्रोटॉन है. दूसरा जो एक्सप्रेशन था हमारा, जो अगर चार्ज नहीं होता तब भी पोटेंशियल एनर्जी होती है, और वो पोटेंशियल एनर्जी सिर्फ काइनेटिक एनर्जी हम कहते हैं दो पार्ट के. सो पी स्क्वायर लीनियर मोमेंटम की वजह से जो पोटेंशियल एनर्जी ये L equal plus 1. So this potential energy comes from that L plus 1 square by x plus 1. Relative mu, the mu r square which is being used, ठीक है, by 2 mu r square. So mu is used wherever you have correlated motion, one with respect to the other. So mu r square is the most important term. So finally, this is what has happened here. We got the equation which has the terms when you wrote Hamiltonian and change the coordinates from x y z to r theta phi. We got an equation which was separable in terms of the coordinates, angular coordinates and the radial. So radial part was taken aside. Another part, the angular part, is here, shown over here. This is called radial wave equation. This is called angular wave equation. Only the angle, the variation of wave function as uh, the angle changes. And here the change in wave function, change in amplitude of the wave as the radius, as the radial distance changes. So this is the thing that you have. So this rearrangement of the equation can give you this V effective that we wrote. So V effective is, so potential energy term, V effective is the electrostatic and then uh, simple fact correlated motion of the. So we need to analyze this potential energy first. Potential energy arises from this two terms. So this is a term, Coulombic potential, energy of the electron in the nucleus which is positively charged. So in the field of nucleus, you will have some energy. The second term, it depends on the angular momentum and it is the centrifugal effect. So something, you are एक पत्थर को बांध के धागे में ऐसे घुमाओगे, उसमें सेंट्रीफ्यूगल इफेक्ट वैसे सोचो, वैसा ही कुछ यहाँ भी हो रहा है कि न्यूक्लियस है, उसके चारों इलेक्ट्रॉन मूव कर रहा है. So that will also have some centrifugal force will be acting on that particle, and that force, that energy due to that interaction, that is given by this. So it depends on angular momentum of the electron around the nucleus, and origin of it is centrifugal effect. So Coulombic and centrifugal, these two together constitute your potential energy. Potential energy में दो term आएगा. When L is zero, the angular momentum is zero. So जब भी आप s orbital की बात करते हैं ना L0, तो वही बात है. Angular momentum, the electron has no angular momentum. So in s orbital अगर आप कहें कि electron has no angular momentum, you are right. Yes. And the effective potential energy is, so there is no centrifugal effect in L is equal to zero. मतलब s orbital में कोई centrifugal effect नहीं. Only this term will be there. So कई बार जो हाइड्रोजन एटम का आप लोग उसमें लिखा मिलता है, सिर्फ यही वाला रहता है, क्योंकि वो हाइड्रोजन एटम को लेकर डिस्कस कर रहे हैं, उसमें है ही नहीं. जो वन के लिए डिस्कशन आएगा, उसमें ये वाला there is no centrifugal effect, there is no potential energy due to this factor, only potential. Whenever L is not equal to zero, anything non-zero value of L, there will be centrifugal effect, and it gives a positive repulsive contribution to the effect potential energy. So this is negative C, the contribution. ये negative है. इसके आगे साइन ये पॉजिटिव, जैसे L बढ़ेगा ये टर्म बढ़ेगा. So this, अगर इलेक्ट्रोस्टैटिक में वो अट्रैक्टिव हो रहा था, तो ये ठीक उसका उल्टा काम करेगा, उसको दूर करेगा. Centrifugal term gives a positive repulsive term contribution to the effective potential energy. Effective potential energy will change with respect to this. So this is proportional to, you can clearly see this is proportional to 1 by r square, whereas so there's two things in potential energy, there are two factors which are working in opposite ways. Centrifugal effect tries to push the two things separately, अलग अलग करना चाहेगा. At Coulombic interaction, positive and negative charge will pass that. So that is, so so in the that, so whenever you have two terms are there, Coulombic term varies at 1 by r, centrifugal effect varies as 1 by r square. So this centrifugal effect dominates. अगर आप पूछा जाए कि वो इलेक्ट्रॉन कोलैप्स नहीं कर जाएगा, न्यूक्लियस में, तो आपके पास इस तरह से आप इसको डिस्कस कर सकते हो। अगर सिर्फ अट्रैक्शन होता तब तो वो कोलैप्स कर जाता, बिकॉज ऑफ दिस सेंट्रीफ्यूगल इफेक्ट दिस हैज थोड़ी डिस्टेंस पर है। सो दिस सेकंड दिस क्या ये ऑर्बिटल में नहीं होगा, तो एस ऑर्बिटल का मैक्सिमम इलेक्ट्रॉन डेंसिटी भी न्यूक्लियस पे होता है। ये भी फैक्टर, ये भी फैक्ट है। आगे चलकर हम देखेंगे। S orbital has maximum electron density at the nucleus, not near the nucleus, at the nucleus with R is 0. इसी का वही चीज जो आप कहना चाह रहे हैं वही चीज बहुत ठीक है। और इसके लिए नोबेल प्राइज मिला था ऑस्कार स्पेक्ट्रोस्कोपी जो है, फोर्थ सेमेस्टर में आप पढ़ेंगे। उसमें S इलेक्ट्रॉन डेंसिटी न्यूक्लियस कैसे चेंज हो रहा है, तो इलेक्ट्रॉन डेंसिटी एट द न्यूक्लियस S इलेक्ट्रॉन का फाइंड, बाकी सारे इलेक्ट्रॉन डेंसिटी और अदर इलेक्ट्रॉन सब का zero electron density at the nucleus, but for S electron the maximum electron density at the nucleus. Okay, but that is so that is another term, probability density. This is मैंने बताया था ना, probability density. Probability is when you multiply with certain volume. Probability zero हो जाएगा क्योंकि छोटी स्पेस में r zero तो इसलिए वो एक आपका जब मैं कहता हूँ शुरू में कि आप अगर जेनरली पढ़ना है तो यू नॉट अंडरस्टैंड दिस पार्ट, क्योंकि वो सीधा जंप है वेव फंक्शन और सीधा प्रोबेबिलिटी फाइनल। But if you reading James sequence, if you are reading Shiva and everything, then they will move gradually. Psi square and psi square multiplied by volume element, that gives you probability. ये कंप्लीट पिक्चर है कि ये जीरो है, यहाँ पे मैक्सिमम होते ही इलेक्ट्रॉन डेंसिटी मैक्सिमम है, लेकिन प्रोबेबिलिटी जो आप डिफाइन करते हैं गिवन वॉल्यूम वो जीरो हो जाता है, क्योंकि जो वॉल्यूम एलिमेंट है उसका जीरो है। वो सब आगे चल के आप डिस्कस करेंगे। So what you are saying is absolutely right. ये ऑर्बिटल में नहीं है सिर्फ इसी इलेक्ट्रॉन की डेंसिटी भी मैक्सिमम है एटॉमिक फेज, which is that मतलब almost like yeah. Okay, the repulsive term is centrifugal 1 by r square. Attractive Coulombic term, which is proportional to 1 by r. So this is the term that dominates. This term, sorry, the Coulombic centrifugal term in presence of both the terms. अगर जहाँ पे L is non-zero, this non-zero L, this term dominates, and you will have overall effect will be repulsion from the nucleus, and then you are there. So the electron is never be found at the nucleus. When L is non-zero, electron can never be found at the nucleus. But when L is zero, electrons have access. In case of this orbital, we do have that kind of situation, and so we were talking about Coulomb potential and this. So the two effective potential energy, the one for L is equal to 0, one for L is not equal to 0. These are two very qualitatively different cases. Close to the nucleus. So when you are viewing a situation very close to the nucleus, how does the two terms, the centrifugal and the Coulombic terms, vary? Then you will find that centrifugal contribution falls rapidly, because 1 by r square term है ना, जैसे जैसे रेडियस जीरो एट द न्यूक्लियस थोड़ा सा मूव करोगे, you will find a very sharp change, variation in the centrifugal force, ठीक है, and Coulombic contribution will also decrease, but the decrease in this will be less. उसमें कम होगा, इसमें बहुत शार्प डिक्रीज होगा। अब थोड़ा हम ग्राफ वगैरह पे जाएंगे तो ये और क्लियर होगा। हाँ, this one, the case where L is zero, you see, it is effective potential energy. It is falling very sharply to zero. the effective potential energy of the electron in the hydrogen atom, and then L not zero. So whenever it is non-zero, it is repulsive. The energy is rising. ये जीरो वाली लाइन को क्रॉस कर दिया है, एनर्जी है, इधर एनर्जी नेगेटिव है, पोटेंशियल एनर्जी इधर पॉजिटिव है, ठीक है। सो ये जैसे जैसे न्यूक्लियस के पास आ रहा है और ऊपर जा रहा है, ये आप देखो यहाँ पे ऐसे जुड़ा है। सो व्हाट वी हैव हियर, zero orbital angular momentum, electron has zero orbital momentum, the effective potential energy is Coulombic potential energy only. Centrifugal effect is absent in that case when L is zero. When the electron has non-zero orbital momentum, the centrifugal effect gives rise to positive contribution, and that is this rising part. So here you are seeing a dip. So एक वेल जैसा सिचुएशन में मतलब potential energy versus radius. You are seeing decreasing, 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 and the well lowest point again rises again. So this potential well will be formed only, this kind of thing is formed only in case of non-zero L. मतलब 1 2 3 ऐसा कुछ भी हो, L zero होगा तो ऐसा कुछ नहीं, energy goes on decreasing continuously towards the decrease. So like this. So centrifugal effect gives rise to positive quantity that is very large, close to the nucleus. We can expect L0 and L0 to be very different near the nucleus. So near the nucleus, so because of these effects, we can also think of wave function to be very different closer to the nucleus. When they are very close to the nucleus, this is, so we have defined U as equal to R into capital R, the wave function. So very close to the nucleus, when R is very small, this term U is 0. So the right hand side of the equation, this term U, E into U will be 0. So we can also ignore the largest term, and okay. So 1 by R square term. So when you combine these things, V effective is this, and when you ignore very close to the nucleus, when you are there, it is the, as I told you that it is the L centrifugal term that dominates. So we can ignore this term and simplify it, write it in this way. इसको हटा दिया, ये V effective था, V effective का एक्सप्रेशन ये है। अब हमने कहा कि वी कैन वेरी क्लोज टू द न्यूक्लियस, न्यूक्लियस पे नहीं है, न्यूक्लियस से थोड़ी सी दूरी पे, very small distance from the nucleus. This factor is small, this is larger, and so we this can be ignored. We are ignoring this term, and only one term appears. V effective को हमने replace किया इससे, और इसमें further we are ignoring this term very close to the nucleus. When we are close to the nucleus, we can ignore this electrostatic interaction. So R is 0, and this, the solution of this in mathematics, an equation which can solve the form of U, the equation that will looks possible is that something a constant, and R to the power L plus 1 plus B to the power another constant. So this kind of solution seems valid, which satisfies it. So that can be verified by substituting this thing in the differential equation. So here R cannot be infinite anywhere, and specifically R is equal to 0, we must set. So when you write this equation and you apply the conditions that you know about, boundary conditions and other things. So when R is 0, or if at any point the wave function cannot go to infinity. So this term, second term, you must set B to be 0. So you have to forget this term is omitted. The mathematics, without thinking of any nucleus and proton, जो mathematical relation mathematics था, उस form of equation में ये वाला हमारा cancel out हो गया. We are left with only this first term, a to the power A into R raised to power L plus 1. So far from the nucleus, R is smaller, this radius is large, and we can ignore all terms in 1R and 1R square. So we are left with this term. So we are applying two different things. When you are closer to the nucleus at R is equal to 0, and when you are away from the nucleus, very far away from the nucleus, and then we put this sign. So this sign means whenever you put this sign, this means asymptotically equal to. So it graph goes like this. So did we? So we have. So if we put the value of u, which was r into r, and try to solve it, then you will have equation. So r d2r by dr square. Then you differentiate r dr to get this equation. So which is equal to this r d2r by dr square, or you reduce this form of equation to this one. So you have simplified this equation, which was appearing over here, into h cross square by 2 mu d2r by dr square. So u to r, we have come back to the original wave function capital R, which is the radial wave function, and this is the acceptable form. So exponential, then as the power of exponent, this is the term, and the term in R, mu e, mass, energy, h divided by h cross square. So, so acceptable solution of this equation for R large, very large value, and E energy small value of energy is this. So the wave functions, all radial wave functions have this profile. They are exponential decay profile, and this when as R increases to infinity, whole term goes to 0. At infinite value, when R is infinity, this whole term will become 0. Okay. So there are two important things that adds here. Closer to the nucleus, radial wave function is proportional to R to the power L. Far from the nucleus, wave function approaches 0 exponentially. So this square of this term gives you radial electron density, capital R square. So this is the wave function, radial part of the wave function, and square of this gives you radial density, and probability of finding an electron at a specific point, and also called probability density. Example. So further analyzing this form of so now you think of L is equal to psi wave function. How it, if you analyze the initial portion very close to the nucleus, न्यूक्लियस के बहुत पास है और कैसे ये बिहेव कर रहा है वेव फंक्शन psi, the radial part of the wave function, e to this says radial sorry exponential form, it behaves like this. So L is equal to 0, you can see very different from all others. ये जो वेव फंक्शन है psi, so amplitude of the wave is highest at 0. जब r 0 है, you are at the nucleus. So this particular function is the highest value. उसके बाद वो पूरा exponential decay करता है. जो वनस का मैं बार-बार बता दूं कैसे तो पहला यही आता है. First one is this L is equal to 0. Your decay profile, exponential decay, and when L is equal to 1, देखिए यहाँ से almost ऐसे rise कर रहा है तेजी से. L is equal to 2, the rise is slow. L is equal to 3, it is even slower. Rise to the wave function amplitude increases very slowly as away from the initial value is 0. So there are the few points that we note here. One, for L is equal to 0, the amplitude of the electron is maximum at the nucleus. Square of this value gives you electron density. So electron density is maximum at the nucleus. Maximum electron density at the nucleus. For L, तो सारे s ऑर्बिटल्स का इलेक्ट्रॉन डेंसिटी अगर आप पूछेंगे तो मैक्सिमम इस पे आता है. Second, you note that other thing. L is not equal to 0, 1, 2, 3. Amplitude of the electron wave is 0 at the nucleus. Then you move away from the nucleus, and so if you extrapolate this to the electron density, that means squaring, when you square this gives you electron density. So here all have 0 electron density at the nucleus. All of them, 1, 2, L, 1, 2, 3. So as L increases, the angular momentum increases, electron density also increases, near the nucleus also increases, और इसकी yeah, centrifugal. So centrifugal force, centrifugal effect जो बढ़ रहा है, तो उसकी वजह से change in amplitude becomes slower. As centrifugal ठीक है. So just one more conclusion from this. When R L is not equal to 0, so you have R to the power L is 0. Okay, when R is 0, R to the power L is 0. There is 0 radial electron density at the nucleus, 0 probability of finding the electron at the nucleus. Okay, clear है? 0 radial electron density at the nucleus because of this term, R to the power L. When R is 0, L is also 0. So वो वहाँ पे 0 नहीं होगा. There is no two situations. And this R is 0 to the power some zero to the power 1 to 3. तो वो 0 होता है. लेकिन यही R to the power L है, and L is 0. So that R to the power L is 1. So ये that's how, so mathematically you can also reach there. So higher the angular momentum, higher the value of L, less likely the electrons to be found near the nucleus. Okay. However, when L is equal to 0, this is equal to 1, even when R is 0, and there is a non-zero probability density of finding the electron at the nucleus. Oh, okay. So exponential decay of wave function, जो ये exponential term है, इसका और एक फायदा ये है कि you can why you represent electron cloud with a circle with a sphere. That is because of this reason. This is the exponential decay represents that uh, wave functions so go to 0 at very large length, so at a distance r. So it can be represented by spheres of well defined radius जहाँ पे आपका maximum 90% तक decay कर जा रहा है. फाइनली वो 0 तो होगा इंफिनिटी पे, लेकिन जहाँ तक 90% वो आपका रेडियस आप डिफाइन करते हैं और सर्कल से रिप्रेजेंट करते हैं, स्फीयर से रिप्रेजेंट करते हैं. So we'll see next part. We'll see about the energy. How we can find out that the next class.